Today's video is the second part of a three-part series about creating a chess game. In this part, we'll implement each piece movement, create an input system, and store data about the game board. In the next part, which will be probably the last one, we will handle the winning conditions, castling move, and pawn promotion. The next part will be available in exactly a week. Let's begin. Let's start by implementing the chess player class. So open the chess game controller script and add 3 private fields for chess player: the white player, the black player, and a reference to the active player, which will be a reference to the white player or the black player. Now let's create our players in the awake method, so add a new method called createPlayers, generate this method. Here we will call the chess player constructor for the white and the black player. The constructor will be initialized with a team color and a board. Now let's implement the chess player class. First of all, this class will not be a mono behavior. We will need 3 properties for a team color, a reference to a board, and a list of pieces which will hold pieces that have the same team as the player and are still on the board. Now the constructor. It will have 2 parameters for a team color and a board. In the body of the constructor, we will assign parameters to the proper fields and set the active pieces list to a new empty list. Like in the class diagram, the chess player has to be able to add a piece to his active pieces list. So let's write a method called addPiece with a parameter of type piece. This method will simply check if the piece in the parameter does not already exist in the list, and if not, it will add this piece to the list. We also need a method that removes a piece from the active pieces list. This method will be very similar to the addPiece method, but here we will remove the piece passed in the parameter from the list if it exists there. And the last method, called generateAllPossibleMoves, will iterate through all of the active pieces in the list, make sure that a piece is on the board, and if so, it will call the selectAvailableSquares method. Now, to be able to move piece at the start of the game, we have to add more functionality to the startNewGame method. First, we have to assign the active player reference to one of the players. In chess, it is always the white player. We also have to generate all moves for the active player, so let's add a method for that. In this method, we will just call the generateAllPossibleMoves method on the player object passing the parameter. Now we will take a little detour and take care of the input system. So let's look at the class diagram again. The input system will be divided into 2 parts, which receive input and the one that takes action on that input. Those 2 parts will be connected by an abstract class called InputReceiver, which has a collection of type IInputHandler as a field. InputHandler's type is an interface that requires classes to implement the processInput method. That way, the input receivers will not care about the specific implementations of input handlers that are connected to them, they will just call for them to act. So let's start with the InputReceiver class. Like I said before, this is an abstract class that holds a collection of type IInputHandler and an abstract method called onInputReceived. In the awake method, we will find components of type IInputHandler, so the receiver and the handlers have to be on the same game object. Now the IInputHandler. It will be an interface that declares one method called processInput and passes all information required to process input in different ways in its parameters, which are the input position, the selected object, and a callback action. Now we can implement our first receiver that will be used for the board, the Collider input receiver. Here we need one field to store information about the click position. In the update method, we check if the left mouse button has been clicked. If so, we shoot a ray from the camera to the clicked position. If you hit a collider, we store the hit position and call the onInputReceived method. In this method, we will simply call the processInput method with the previously stored clicked position as a parameter on every handler that is attached to the same game object. Now let's create our first handler, which will be the board input handler. Every handler needs to implement an iInputHandler interface, so let's add it and declare the processInput method. Here we will pass the input position to the board, so let's add a field that will refer to a board. The board input handler will be a component attached to the board game object, so let's cache it in the awake method. Let's also add the require component attribute. In the processInput method, we will simply call a method on the board object with the input position as a parameter. Let's call the method onSquareSelected and generate it. Back in the board script, we have to store the information about which piece is placed in which square somewhere. The best data structure for this is a two-dimensional array of type piece. So let's declare such a field and call a method that will initialize such an array in the awake method. The size of one of the dimensions of the array will be assigned in a constant field in the board class. Let's name this variable board size and initialize it to 8, which is the standard size of a chessboard. I can see that the hasPiece method was left out, so let's quickly implement it. Here we will use a nested for loop to iterate through grid and compare each element to the piece passed in the method's parameter. If it is the same, we will return true. If we don't find such a piece in the grid, we will finish the loop and return false. Now let's take care of the method that will be called when the player clicks on the board. First we have to convert a word position passed in the parameter to a square coordinate. Let's declare such a method with vector3 as a parameter. Here we have to divide the input position components by the size of the square and floor them to integer. That will give us coordinates in range -4 to 3. To convert them to 0 to 7 coordinates, we have to add half of the board size value. I made one mistake here. The input position should be converted to a local position of the board. It works here because the board's transform position in the scene is in the word origin. Here is the fixed code. Back in the onSquareSelected method, based on the calculated coordinates, we have to check what piece is located in those coordinates. So let's add a method that will just do that, and let's call it getPieceOnSquare with vector2int coordinates as the parameter. In this method, we will first check if the coordinates passed in the parameter are not outside of the board. If not, we will return the piece on that square. Otherwise, we will return null. The returned value can be null even if the coordinates are on the board, because not every square has a piece on it. Let's quickly implement the check if coordinates are on board method. This method will take each component of the coordinates passed in the parameter and check if their value is not lower than 0 or not bigger or equal to the board size. If all of those conditions are met, we return true, otherwise we return false. Back in the onSquareSelected method, we will need to know if any piece is selected right now, so let's add a field for this class called selectedPiece. Now we can check if any piece is currently selected. If yes, we have to check if we are selecting the same piece first. And if so, we just deselect this piece. Let's generate a method that will take care of deselecting a piece. In that method, we will just set the selected piece reference to null for now. If you select the same piece, let's check if you are selecting a different piece from the same team as the active player's team. We need some information about the players, but we don't really want the board to know about the players, so let's use the chess game controller as a facade to get information from players. So let's add a class field for the chess game controller. Now to set this reference to an object, let's add a method called setDependencies that will pass the chess game controller in its parameter. Let's quickly go back to the chess game controller class and call the setDependencies method from the board class in the startNewGame method. In the parameter, the chess game controller will pass itself. Back in the onSquareSelected method in the board script, we can use the chess game controller reference to check if the selected piece is from the same team as the active player. If all of the above conditions are met, we are able to select a different piece with the selectPiece method. The selectPiece method will just take the piece passed in the parameter and assign it to the selected piece variable. We also need to implement a method that will check if a piece passed in its parameter is from the active player's team. So back in the ChessGameController class, let's create such a method. Here we will return true if the team color passed in the parameter is the same as the active player's team. Otherwise, we return false. If you are not clicking on any of the pieces in our team, we can check if the selected piece can move to that square. If yes, we call a method that will be responsible for moving a piece that takes the selected piece and the coordinates as parameters. When a piece is moved, we have to update the data in our grid array. So let's add such a method. In its parameters, we will pass the coordinates that a piece is moving to, its old coordinates that are stored in the occupied square variable in the piece object, the piece that is being moved, and the piece that was there in the old coordinates. This value will be null when moving a piece, but will come in handy, for example, when we want to undo a move. In the body of the method, we will set the old piece in the old coordinates in the grid and the new piece in the new coordinates of the grid. Back in the onSelectedPieceMoved method, we will call the movePiece method on the selected piece, deselect it, and add the active player's turn. The endTurn method will just call a method with the same name in the ChessGameController. The ChessGameController will handle ending a turn because it is the only one that knows about chess players. Let's generate such a method in the ChessGameController. In this method, we will generate all possible moves for both players after the board changes its state. Then we will change the active team. Let's add a little helper method that will return an opponent to the active player. In the changeActiveTeam method, we will simply change the active player from white to black or from black to white. Let's go back to the board script and the onSquareSelected method and handle situations where no piece is selected. Here we have to check if you are clicking on a square with a piece on it and check if this piece is a piece with the same team as the active player's team. If yes, we can select this piece. In the first part, we skipped through the movePiece method in the piece class. Now we are ready to take care of this. First, we have to calculate the word position from the coordinates passed in the parameter. Then, set the occupied square variable to the parameter coordinates, set the hasMoved variable to true, and ask our tweener object to move the piece transform to the previously calculated word position. Now, let's take care of the tweeners. First, we have to create an interface that every tweener class will implement. This interface will require implementing classes to have a method called move2, which takes a transform and a vector3 as parameters. Let's open the instant tweener script and declare it as an iObjectTweener. We have to implement the move2 method, and we will just set transform position to the target position here. Back in Unity, we have to fix our piece prefabs. Because we changed the iObjectTweener from a class to an interface, and we already hooked it up as a component to prefabs, we will get an error script. What we have to do is to add the instant tweener to every prefab and remove the corrupted component. And let's also add a board input handler and a collider input receiver components to the board game object, so we'll be able to receive input from the board. Let's go back to the ChessGameController. During the board generation, we need to set initial data in the grid array in the board object. So let's add a method for that called setPieceOnBoard with coordinates and a piece as parameters. In this method, we will first check if the coordinates from the first parameter are on the board And if yes, we will simply set the piece from the second parameter in the grid with the coordinates passed in the first parameter. Back in the chess game controller, after setting the new piece on board, we have to assign it to proper player. We will choose the player based on the piece color and add it using the addPiece method in the chess player object. One small mistake to fix in the check if coordinates are on board method, I typed minus sign instead of equals sign. Now to check all systems that we have just created, we have to give our pieces some possibility to move. So let's add some simple implementation of the select available squares method. We will make all pieces move only one square ahead from the currently occupied square. And one quick fix that I pointed out in the previous video, if we have to return the instantiated piece, not its prefab. Now let's go back to Unity and see if we can move any piece. And there we go, we can move our pawn one square ahead. The input system and the tweener component is working as intended. Now let's implement our piece movements correctly and start with the rook. We will need an array of vector to int that will define in what directions on the board a rook can move. Those directions are left, right, up, and down. In the method, first we have to clear the available squares list that may hold moves from previous board data. Then we need to define how far the piece can move. The rook is limited only by the board size, so let's use that variable as the range. Now we can iterate through all directions and find available moves. In every direction we have to add another loop that will move to the next square in the current direction. For each square, we have to calculate its coordinates. After calculating the next square coordinates, we want to check which piece, if any, is on that square. We have to make this method public, and as long as we are here, let's also make the check if coordinates are on board method public. Now let's check if the coordinates are not outside of the board. And if they are, we can just break out of the loop. Then we should check if there is no piece on the next square, and if so, we can add it to the available moves list. We should also check if there is a piece from the opposing team. If yes, we can also add this square to the available moves list, but we cannot jump over the opponent's piece, and we have to break out of the loop and check the next direction right away. The last check will be to see if the piece on board is from the same team. Here we cannot move to that square and cannot jump over this piece and have to break out of the loop. At the end, after checking all directions, we just return the available squares list. The bishop is very similar to the rook, but it will have different move directions. Those directions will be all diagonal directions. The bishop will check squares in the same fashion as the rook, so let's just copy the select available squares from the rook script. Now that I think of it, we could go more towards composition instead of inheritance in piece implementation. Instead of having classes inheriting from an abstract class, we could add a field to the piece class that would hold a list of move behaviors that would implement some interface. Those behaviors would be like line movement for rook, bishop, or queen, point movement for knight, and so on. The advantages of that would be that we would not need to copy the code like we are doing right now, and it would be easier to create some non-standard pieces. The queen will be almost the same. We will copy the directions from the bishop class and add the rook directions, because the queen is basically a rook and a bishop in one. We can also copy the select available square method from the bishop or the rook class and copy it in the queen class. Now the knight, something new. First, we have to define all squares that the knight can jump to. Let's call this array offsets. And we have to declare all L-shape vector2 int values. As always, we have to clear the available moves list first, then we have to iterate through all offsets and find a square in coordinates equal to currently occupied square plus the current offset in each loop iteration. Next, we get the piece on the calculated coordinates and check if those coordinates are on the board. If they are, we add a move only when there is no piece on the next square or the piece is from the opposite team. After the loop ends, we return the available moves list. Now the king, which again will be almost the same as the rook, bishop and queen. So let's copy one of the implementations and paste it into the king class. One thing that will be different is the movement range. The king can only move one square in each direction. So let's copy the offsets list in the knight class and change the direction coordinates a bit. Let's also rename it from offsets to directions. Now the weirdest piece, the pawn. We will not declare any directions in the class field, but we will define a direction based on the team color. White pawns will move up the board and black pawns will move down the board. Next, the move range will be 2 if a pawn has not moved yet, or 1 if this is not its first move. Now we can add a for loop that will check the moves ahead of a pawn. I think I added a little bug in the previous pieces. When looping through the range in a move direction, I skipped the last move, so let's fix that by adding a equal sign to the loop end condition. Back in the pawn class, as always, we find the piece on the next square and check if the next square coordinates are on the board. If yes, we check if there is no piece on that square. Only then we can add it to the available moves list. Otherwise, we break out of the loop. But that's not all. The pawn can also move one square diagonally to take an opponent's piece. So let's take care of it separately. First, we have to define all diagonal directions based on the pawn forwards direction. Then we have to iterate through those directions and, like before, find the next square in the diagonal direction, check its coordinates are on the board, and if so, add to moves list, but only when there is an opponent's piece there. And one small mistake here, we have to add the take directions to the occupied square here. Now let's go back to Unity and see if we can move our pieces properly. And here we go, the implementation works. The last thing we have to add is the functionality of highlighting squares that we can move to. So let's take a look at the class diagram and see where we can find it. As we can see, the square selector is a component on the board game object, so let's go to the board class and add it as a member field. First, add a require component attribute and declare the square selector as a member field. Because the square selector will be a component on the board, let's cache it in the awake method. Then let's open the square selector creator class and we will take care of it now. Here we need a reference for a material that will highlight a free square and a material that will highlight a square with an opponent's piece on it. A reference to a prefab that will be used to highlight a square, and a list that will add all instantiated selectors to. Now let's declare the first method called showSelection that takes a dictionary with the square's word position as a key and a boolean value that will hold information if the square is empty or not as a value. First, we have to destroy all previously instantiated selectors, so let's add a method that will just do that, and call it in the showSelection method first. Then we will use the for each loop to iterate through all the key value pairs in our dictionary and instantiate selector in position held in the key. Then we have to add the new selector instance to the instantiated selectors list. And of course, after destroying all selectors in the clearSelection method, we have to clear the list as well. And lastly, we need to find all material setter components attached to the selector and change its material based on information about the presence of a piece in the square. Let's make the clearSelection method public. Now let's go back to Unity and create two materials for our square selector. Then find the board game object and add the square selector component to it and assign the material references. For the selector prefab, I created an object consisting of 4 scaled cubes. Each of them has a material setter component on it. Now we can drop it as a reference for the selector prefab in the square selector inspector. Now we need to find a place to call the square selector, and that place is the select method in the board class. So after setting the selected piece reference, we get the available moves from the selected piece and pass it to a method that will highlight squares. Let's call this method showSelectionSquares. Let's generate it. First, declare a dictionary that will hold data for the square selector. Then we will iterate through all available squares and calculate a world position from them. Then, if there is a piece on that square, we will keep that information in a Boolean value. And lastly, add a new entry to the dictionary with the position as the key and the Boolean variable as the value. After the loop ends, we just call the showSelection method on the square selector with the dictionary as the parameter. And the last line of code in this part, in the deselectPiece method, we have to call the clearSelection method in square selector. Now let's go back to Unity and take a look. As we can see, the available squares are highlighted, the empty spaces are green, and the squares with the pieces on them are red. This is the end of the second part. In the next one, we will implement winning conditions, castling move, and piece promotion. We'll also add a little UI using our input system. As always, you can find the whole project on GitHub in the description below. I hope you enjoyed it, and please like and subscribe if you like my content. Also, leave a comment, I'm happy to answer all of your questions. Take care.